Imagine you're looking up at the night sky. Everything feels silent, peaceful, but somewhere, billions of light years away, a dying star unleashes a flash so powerful that for a few seconds, it releases more energy than our sun will produce in its entire 10 billion year lifetime. This isn't science fiction. It's called a gamma ray burst, the most powerful explosion ever observed in the universe. If one of these invisible beams were aimed directly at Earth from close enough, the consequences could be catastrophic. Not because it would blow the planet apart, but because it could silently strip away our atmosphere's protection, exposing life to deadly radiation. The terrifying part? These events happen across the universe far more often than most people realize. Every day, astronomers detect gamma-ray bursts somewhere in the cosmos. Most are unimaginably distant. Most never threaten us. But one question has haunted scientists for decades. What if the next one didn't miss? To answer that, we have to travel billions of years into the violent life of the universe, where stars don't simply die. They create the brightest flash nature has ever known. The universe wasn't always calm. In its early history, it was a far more violent place, a cosmic battlefield, where enormous stars lived fast and died young. Many were over 100 times more massive than our sun, burning through their fuel in just a few million years before collapsing under their own gravity. When one of these giants reached the end, its core imploded in a fraction of a second. The collapse was so extreme that it often formed a black hole or an ultra-dense neutron star. But the story didn't end there. As surrounding matter spiraled inward at incredible speeds, magnetic fields twisted into unimaginable strength. Then, without warning, two narrow jets of pure energy erupted from the star's poles, punching through the dying star at nearly the speed of light. For a few seconds, those jets became gamma-ray bursts, the brightest flashes ever witnessed in the universe. Unlike an ordinary explosion, their power wasn't spread in every direction. It was concentrated into razor-thin beams, making them unimaginably destructive to anything caught directly in their path. And somewhere across billions of galaxies, those invisible beams are still racing through the darkness, carrying a question no civilization would ever want answered. The first gamma-ray burst wasn't discovered by astronomers searching the stars. It was discovered by soldiers searching for war. In the late 1960s, at the height of the Cold War, the United States launched a series of secret satellites called Vela. Their mission was simple: detect illegal nuclear explosions in space and ensure no country was secretly violating the Nuclear Test Ban Treaty. Then, something impossible happened. The satellites began detecting sudden bursts of extremely powerful gamma radiation. But these flashes weren't coming from Earth, or even from our solar system. They were arriving from random directions across deep space. For years, scientists were completely baffled. No known object could produce such intense bursts of energy. They appeared without warning, lasted only seconds, and vanished before telescopes could even react. Every new detection deepened the mystery. Had astronomers discovered an entirely new kind of cosmic catastrophe? Or was the universe hiding a phenomenon so extreme that no one had ever imagined it could exist? It would take decades of observations and one revolutionary space telescope to reveal the terrifying truth behind these mysterious flashes. By the late 1990s, astronomers finally uncovered the truth, and it made gamma-ray bursts even more terrifying. These weren't ordinary explosions. If a gamma-ray burst released its energy equally in every direction, it would still be astonishing. But nature had chosen something far more dangerous. Almost all of that unimaginable energy is squeezed into two incredibly narrow jets, launched from opposite sides of the collapsing star at more than 99.99% the speed of light. Imagine replacing a light bulb with a laser. The amount of energy stays immense, but instead of spreading everywhere, it's focused into a beam capable of crossing entire galaxies. That is why gamma-ray bursts are so destructive. Most planets will never even notice one. But for the rare world caught directly inside that cosmic spotlight, the experience could be devastating. Fortunately, space is unimaginably vast, making such alignments extremely uncommon. Yet every time astronomers detect one of these distant flashes, one unsettling thought lingers. Somewhere in the universe, there could be a planet experiencing that beam right now. Now comes the question that makes gamma-ray bursts so unsettling. What would actually happen if one were aimed directly at Earth? Contrary to what Hollywood might suggest, the planet wouldn't explode. Buildings wouldn't instantly shatter, and continents wouldn't be torn apart. The real danger would be far more silent and far more terrifying. As the beam struck our atmosphere, an enormous flood of high-energy gamma radiation would collide with air molecules, triggering a chain of chemical reactions. Those reactions could rapidly destroy large portions of the ozone layer, the invisible shield that protects every living thing from the sun's harmful ultraviolet radiation. With that shield severely weakened, intense ultraviolet light would pour onto Earth's surface. Plants, plankton, and entire marine food chains could suffer catastrophic damage. Ecosystems that took millions of years to evolve could begin collapsing from the bottom up. The frightening part is that the gamma-ray burst itself would last only seconds, but the environmental consequences could unfold over months, years, even decades. And scientists believe Earth may have experienced something disturbingly similar long before humans ever existed. This isn't just a terrifying thought experiment. Some scientists believe Earth may have already been caught in the path of a distant gamma-ray burst. Around 443 million years ago, during the late Ordovician mass extinction, nearly 85% of marine species disappeared. It remains one of the 5 greatest extinction events in Earth's history. The exact cause is still debated, but one intriguing hypothesis suggests that a nearby gamma-ray burst may have triggered a chain of atmospheric changes. The idea isn't that the burst directly killed life with radiation. Instead, it may have stripped away much of the ozone layer, allowing intense ultraviolet radiation from the sun to bombard Earth's surface for years. Tiny marine organisms, the foundation of the ocean's food web, would have been especially vulnerable, potentially setting off a devastating ecological collapse. There is no direct evidence proving a gamma-ray burst caused the Ordovician extinction, and several competing explanations exist, including rapid climate change and glaciation. But the possibility remains scientifically plausible enough that researchers continue to investigate it. If that hypothesis is ever confirmed, it would mean the deadliest explosion in the universe has already changed the history of life on Earth. If gamma-ray bursts are capable of reshaping worlds, then the obvious question is, are we safe today? The reassuring news is that astronomers don't know of any nearby star currently aimed at Earth that is likely to produce a dangerous gamma-ray burst. Most bursts occur billions of light-years away, and by the time their light reaches us, they pose no threat. But unlikely is not the same as impossible. The Milky Way still contains massive stars racing toward violent deaths. If one were close enough and its narrow jet happened to point directly at Earth, the consequences could be severe. Fortunately, the odds of that precise alignment are considered extremely low. Even so, astronomers constantly monitor the sky. Space telescopes detect gamma-ray bursts almost every day, not because they expect one to threaten Earth, but because each burst reveals new clues about black holes, neutron stars, and the evolution of the universe. Ironically, the deadliest explosions ever discovered have become some of science's greatest teachers. They remind us that in a universe filled with unimaginable violence, our planet has been extraordinarily fortunate. But there is one gamma-ray burst that changed astronomy forever, and it was so powerful that it briefly became the brightest object ever recorded in the observable universe. On October 9, 2022, astronomers witnessed the most powerful gamma-ray burst ever recorded. Officially named GRB 221009A, it quickly earned a simpler nickname, BOAT. The brightest of all time. Originating nearly 2.4 billion light-years away, its radiation was so intense that it temporarily overwhelmed instruments built specifically to study events like this. For days, scientists watched its fading afterglow, uncovering new clues about black holes, collapsing stars, and the most extreme physics ever observed. Fortunately, BOAT was far enough away that it posed no danger to Earth. In fact, astronomers know of no nearby gamma-ray burst currently capable of threatening our planet. But BOAT served as a powerful reminder. These unimaginable explosions are not science fiction. They are real. And they are still happening. Every night, we look up at the stars with wonder. Yet hidden among those same stars are forces powerful enough to outshine entire galaxies in just a few seconds. The universe doesn't act with mercy. It doesn't act with malice. It simply follows the laws of physics. And among every phenomenon we've ever discovered, nothing rivals the terrifying power of a gamma-ray burst.